Thank you for the introduction. I'm Yinping Ma from Peking University, and then my topic of my presentation today is our self-development open source software SCOW and CraneSched. This presentation will unfold from three perspectives. First, I will introduce the construction experience of the high-performance platform of Peking University, and the second, I'll explain the core technological breakthroughs of the computing portal SCOW and the computing schedule system. I'll demonstrating the practical results through typical application cases. Let's first focus on the history of HPC platform of Peking University. I'll first introduce something about Peking University. Originated as the Imperial University of Peking in 1898, PQ was China's first comprehensive university and the supreme education authority at the time. In recent years, PQ has made remarkable achievements in disciplinary development, student training, and scientific researches, which has laid a solid foundation to build PQ into a world-class university. Since the inauguration of HPC platform in 2018, we have successfully built 5 advanced clusters, including China's first warm water-cooled cluster, WIMI number 1, and the first domestically produced 100 gigabyte high-speed network, WIMI number 2. The platform serves over 7,800 faculty and students from 110 departments across the university, with the main cluster maintains an annual utilization of about 18%, effectively supporting interdisciplinary scientific innovation. In the past 7 years, the platform has supported the production for more than 2,300 high-level papers in Nature, 22 in Nature, and over 130 in Nature series. And it also facilitated approval of over 600 projects, about 4.5 billion Chinese yuan. It is especially worth mentioning that among the research development of academic Gowan won the 2020 National Technological Innovation First Prize. More than 18 papers were supported by the platform's computing power, providing a total of 35 million core hours of computing resources. In 2020, academician overnight team won the Nobel Prize of Supercomputing, the Golden Bell Prize, pioneering the AI for science research paradigm, and the platform fully supported the research from theoretical breakthrough to practical verification. In terms of talent cultivation, we have continuously held PQ University high performance computing comprehensive ability competition. The 2025 competition attracts over 700 participants from over 114 universities nationwide, achieving remarkable results in fostering computing thinking. Our team led the PQ University supercomputing team to win the overall champions of World University Students Supercomputing Competition in both 2024 and 2025, as well as the highest impact performance award of SC 2023. Now we come to the third part, our software innovation of our team. This is our self-developed computing technology stack. Which contains 6 core components. Now we look to the left. We have developed the computing schedule CraneSched, the computing platform SCOW, and the large language model intelligent assistant Xiaoshuan, and the remote desktop Shadowdex. This is our software between in one single computer center. We have developed two software to build a one single platform to a computing network. it's about the computing power network scheduling system CraneSched and computing power network integration platform SCOW. Now we focus on the computing schedule CraneSched. CraneSched addresses two six critical industry pain points: the hyper scalability bottlenecks, the high throughput small job processing efficiency, and the insufficient containerization support, and the limited adaptation to Chinese domestic chips, and the limited scheduling strategies, and the long-term resources fragmentations. To solve these problems, we developed the open source CraneSched computing scheduler, and we also provide an online environment for users to try it out. It's totally open source. CraneSched adopts three-layer architectures. The resource layer achieves a unified management of heterogeneous hardware. The scheduling layer uses innovation algorithm to ensure optimal resource allocation. The application layer provides a multi-scenario interfaces and cross-platform adaptations, significantly lowering the usage barriers. The core advantage of CraneSched lies in deep integration of supercomputing and intelligent computing, with native speed support for container technology such as Singularity, Docker, and Podman. Perfect adapting to large model training and inference scenarios. CraneSched is fully compatible with x86, ARM, and RISC-V architectures, support major OS such as CentOS, Ubuntu, Rocky, and OpenEuro, and achieves full-stack adaptation for CPUs like Intel AMD Phaeton High-Guang, and accelerators like NVIDIA and AMD GPU and Chinese High-Guang DCU and Huawei Ascent GPU. Actual tests show that the CraneSched scheduling performance reaches about 20 that of Slurm and 5 times that of OpenPBS. Compared with similar products, we can show our data in the tables. The CraneSched is internationally leading in three key metrics. It's about supporting cluster size, number of scheduling classes per hours, and number of tasks running simultaneously. 2 months ago, a paper on CraneSched was accepted by the ICS conference, proposing an online retrieval augmented language model methods for job running prediction on HPC platform, which improves the prediction accuracy by 41%. CraneSched innovation adopts a dual-stage prediction mechanism, and the first stage identified job types, and the second stage accurately predicts runtime. In tests on 3 PQ clusters, average job waiting time is reduced by 35%, and the resource utilization improved by 28%. And we have also proposed an automated power control algorithm, which dynamically adjusts the node power on, power off, and also sleep states based on the cluster utilization, saving power costs and reducing energy consumption. Now we come to the computing platform SCOW. SCOW is committed to solving three major pain points of the computing center. It's about first is complex operation management, and the second is a high user threshold and the difficulty in resource integration. As the central hub of the computing center, SCOW delivers a 3-in-1 solution that combines usage optimization, management efficiency, and the system integration capabilities. SCOW consists of 2 systems. The first is a cluster management system, and the second is a user port system. For a cluster administrators, SCOW provides a rich management function than the HPC platform management, user account management, and billing modes, make the system easy to manage. For users, SCOW enable programming and job submission without installing any software, make it especially user-friendly for the beginners. SCOW is ready to use out of the box, enabling rapid development and server provision, as well as convenient subsequent operation and maintenance upgrades. And SCOW is a totally open source projects, and you can get detailed information about the project through these links. And we have an online demo. You can log in and try it out. SCOW has developed a new UI for the intelligent computing scenarios, supporting common functions such as model management, data management, and image management. For cross-computing center network scenarios, we develop SCOW at each computer center. Like this is one computer center, and there is four more computer centers. We can link this computer center through our SCOW products to form a computing network. In the field of computing scheduling and computing network, we have led or participated in formulating one IEEE international standard and three Chinese national standards and four group standards, promoting the standardization of the industry. At present, SCOW system has been deployed in 58 computer centers across China, including 37 universities and 12 enterprise users. The OpenSCOW image has surpassed 31,000 downloads worldwide, covering users including Algeria, Japan, Singapore, and the US status. This demonstrates the significant international influence of SCOW. Next, I will introduce our self-developed large language model intelligent assistant Xiaoshuang and remote desktop shadow desk. While managing and maintaining HPC platform of Peking University, we found that users often ask repeated questions about payments, account creation, and acknowledgement, and so on. We leveraged a current large language model RAG technology to help administrators quickly build an intelligent agent to address users' platform usage questions. Xiaoshuang features a rapid containerized deployment, multi-intention sentimental understanding, traceable question and answer, and a high accuracy, efficient text parsing. Xiaoshuang has been deployed on the PQ platform to provide 24/7 intelligent service, improving service quality and reducing costs while increasing efficiency. Now, our self-developed remote desktop shadow desk allow users to visualize data directly on the cluster without downloading data to your own laptop, supporting high resolution, low latency, and hardware acceleration. It supports both Windows and Linux clients. Shadow desk supports a variety of application scenarios such as CAE, EDA, and bioinformatics. For example, this is an automotive crash simulation experiment. You can see the video that shows Shadow Desk can display the simulation process with very smooth animation. Now we came to the third part case study. The first case is our Peking University HPC platform. There are four paid clusters on the PQ platform, built in phases and located in different campuses and different buildings. We manage these four clusters through a single SCOW, and the users can log into the SCOW using the PQ's unified authentication system and you to use the four different clusters. Among the four clusters, the excellent central cluster using the Huawei Accent and Kunpeng servers, mainly for deep learning, large model training, and inference tasks. As shown in the architectural diagram, the underlying scheduling uses CraneSched and Kubernetes, while the app management system uses SCOW AI portal system. The cluster was launched at the end of last year and has received very positive feedback. For intelligent computing, we have adapted many large model related frameworks, including inference frameworks such as VLM and MindIE. Currently, models such as DeepSeek, Chainone, and Llama are running efficiently on the cluster. The SCOW AI system is specially designed for intelligent computing scenarios, with common functions such as model training, image management, and application management, which can well support large model training and inference tasks. The second case is the joint development project with the Chinese Unicom Guangdong for a heterogeneous computing center interconnection and scheduling software. Together with China Unicom Guangdong, we have jointly developed a super intelligent computing integration platform, managing both supercomputing and AI computing resources to maximize resource utilization efficiency. And we have jointly developed an intelligent computing platform based on the Kubernetes system, with core capabilities such as model training, deployment, and management, achieving the integrated of model training and inference. We also have deeply cooperated with Pengchen Laboratory, Huawei, and Xfusion to achieve high integrated computing power. Large model scheduling and file system, and other capabilities, building a complete intelligent computing software and hardware ecosystems. The third case is the Ministry of Education, University AI Campus Sharing Platform. At the end of 2023, we provided a fundamental software system for the university intelligent computing integration and sharing platform by the Education Management Information Class Center and of the Ministry of Education, aiming to promoting the sharing of computing resources and among universities. Currently, about over 10 universities have connected their computing resources to the platform, and the faculty and the students over it's 17 universities have already can log in and use this platform. It's a little demo. This case shows that we have initially realized the integrated computing network, and this can be further expanded to form a university computing network in China in the future. Every user can log into this platform, can use the 10 university computer resources, and can to submit jobs and to train your large language models. Thank you for all your attention.